Let's start.
Good morning to one and all. Myself I am Nandini and my teammates are Tulasi, Sirisha, Saraswati, Anil Kumar and Lavanya. We are from Government Degree College of Sciences, Nagarkurnool. Today our topic is applications of eigenvalues. The topic was supervised by the M. Andai Sir Garu and the aim of the topic is applications of eigenvalue originally used to study the principal axis of rotational motion of rigid bodies. Eigenvalues and eigenvectors have wide range of applications and the introduction of the topic is eigenvalues and eigenvectors feature prominently in the analysis of linear transformations. Eigen is a German word which meaning the proper or characteristics. It is used to study the principal axis of rotational motion of rigid bodies. Eigenvalues are often introduced in the context of linear algebra or matrix theory. Next, one by Sirisha.
Now, history of eigenvalues. In the 18th century, Euler studied the rotational motion of rigid body and discovered the importance of principal axis. Where Lagrange realized that the principal axis are the eigenvalues of the inertia matrix. In 19th century, Cauchy used to derive classified quadratic surface and named this term as characteristic root. Now they are called as eigenvalues. The first algorithm for computing eigenvectors and eigenvalues are appeared in 1929. Where the definition of eigenvalues is scalar lambda is called an eigenvalue of n by n matrix A if there is a non-zero of Ax equal to lambda x such an x is called an eigenvector corresponding to the eigenvalue lambda. An eigenvalue of a square matrix is scalar that is usually represented by the Greek letter lambda. Eigenvalues are the properties of square matrix. In general, a matrix, however, a vector by changing both its magnitude and its direction. However, a matrix may assign certain vectors by changing only their magnitude and leaving their direction unchanged or possibly reserving it. These vectors are the eigenvectors of a matrix. A matrix acts on a vector by multiplying its magnitude by factor which is positive if direction is unchanged and its negative direction is reversed. This factor is the eigenvalue associated with the eigenvector.
Finding eigenvalue. The basic equation in eigenvalue problems Ax equals to lambda x. To find the eigenvalues of n by n matrix A, we write Ax equals to lambda x as Ax equals to lambda Ix or equivalently A minus lambda Ix into x equals to 0. First as non-zero solution if and only if that of A minus lambda A equals to 0. Second is called the characteristic equation of matrix A. The scalar satisfies this equation or eigenvalue of matrix A. When expand, that of A minus lambda I is a polynomial in lambda is called the characteristic polynomial of matrix A. The set of eigenvalues of matrix A is spectrum of A. For example, find the eigenvalues of 3 by 3 matrix A equals to 1, 2, minus 1, 1, 0, 1, 4, minus 4, 5. Given matrix A, 1, 2, minus 1, 1, 0, 1, 4, minus 4. The characteristic equation of matrix A, that of A minus lambda I equals to 0. That of 1 minus lambda 2 minus 1, 1 minus lambda 1. 4 minus 4, 5 minus lambda equals to 0. We can find that of equation, we get lambda 3 minus 6 lambda square plus 11 lambda minus 6 equals to 0. The roots of the eigenvalues of 1, 2, 3.
Applications of eigenvalues in physics. Eigenvalues and eigenvectors have many applications, particularly in physics. Consider rigid physical bodies. Rigid physical bodies have a preferred direction of rotation about which they can rotate freely. For example, if someone threw a football, it would rotate around axis in the air. If someone hit the ball in the air, the ball would be likely to flop. Although this may seem like common sense, even rigid bodies have a more complicated shape, will have preferred direction of rotation. These are called axis of inertia. And they are calculated by finding the eigenvectors of matrix called the inertia tensor. And next one is design car stereo system. Eigenvalue analysis is also used in the design of the car stereo systems where it is helps to reproduce the vibration of car due to the music. Meridian sound system, which is mostly used in the luxury cars, are based on the principle of eigenvalues and eigenvectors. Application in mechanical engineering. Eigenvalue and eigenvector allow us to reduce their linear operation to separate and simpler problems. For example, if stress is applied to a plastic solid, the deformation can be dissected into principal direction. Those directions in each principal deformation is greatest. Vector in the principal directions are the eigenvector and the percentage deformation in each principal. Electrical engineering. The application of eigen information. In civil engineering designing bridges, eigenvalue and eigenvector are used designing bridges. The best example of the Tacoma Bridge built in 1940. However, an incident took place in 7th November 1940 on Tacoma Bridge. Unfortunately, the bridge is collapsed just 4 months after it was built. Tacoma Bridge is said to be a failure in engineering creations, as an proper importance was given to aerodynamics of bridge.
Eigenvalue application in oil companies. Oil company frequently use eigenvalue analysis to explore land value. Oil, dirt and other all substances give rise to linear systems which have different eigenvalues. So eigenvalue analysis can give a good indication where the resources are located. Oil company place roads around a site to pick up the waves that result from a huge truck to vibrate the ground. The waves are changed as they pass through the different substances in the ground. The analysis of this wave led oil companies possible to drill the sites. Conclusion: eigenvalue vectors are fundamentally used in data science model building in general. Besides their use in PCA, they are employed namely in spectral clustering and image compression. Hence, it is important to have clear mind their geometrical interpretation. References: A.K. Ghatak, I.C. Goyal and A.J. Chui, Mathematical Physics. P.K. Chattopadhyay, Mathematical Physics. Thank you.